Welcome to Eureka Math. I'm Mr. Shankel. I'm going to be helping you today with Module 1, Lesson 7. Let's get started. Okay, so we have two facts that we're going to talk about today, and that is the number 10 raised to any large number. So if we see that we have a 10 raised to any large positive integer, that we know that there is a power of 10 that exceeds m. So if our number, whatever it happens to be, is raised to a large exponent, we know that there is one power of 10 that is just bigger than that. So we're going to find out how to find that number. And likewise, if we have a negative exponent, a large exponent, there's going to be a power of 10 with a negative that is smaller, just barely smaller. So let's look at how this is going to work with, we have a rather large number. This is 993,456,789,098,765. All right, so if we take that number, we can say that if I have 15 digits there, I can say that the largest number with 15 digits would then be 999 trillion, 999 billion, 999 million, 999,999. So that number is the biggest that we could get with a 15-digit number. And then in order to get to the next power of 10, well, I would have to go one bigger. So I'd have 1 quadrillion and then 15 zeros. So let me just add all these zeros in. So that is 1 quadrillion, and that would be equal to 10 to the 15th power. Okay, so 10 to the 15th would be the smallest power of 10 that will exceed our number, which was 993,456,789,098,765. All right, so we're just basically finding the first power of 10, so 10 to what, that is just barely bigger than the number that they gave us. Okay, let's look at exercise 2. Exercise 2, we have 78,491 and 899,987ths. So the next biggest number would be 78,492, and we could say that number is just a little bit smaller than the biggest number with 5 digits would be 99,999, and that's just a little bit smaller than the next power of 10, which would be 100,000. So we would have 100,000, and then what power of 10 equals 100,000? Well, that's 10 to the 5th power. And if you notice, if I back up to exercise 1, notice that we have 15 digits here, 3, 6, 9, 12, 15 digits, and notice what our exponent turned out to be, 10 to the 15th. And if I go to our exercise 2, we started out with 1, 2, 3, 4, 5. There were 5 digits there, and notice what our exponent ended up being, so 10 to the 5th power. So if we just count the number of digits, that will tell us what our exponent would be to get just barely bigger than the number that they gave us in 10 to some power. All right? Exercise 3 gives us the general case. So let's say we have 99 and then ... 9, and that just keeps on, that's any number of digits, the biggest number from any number of digits. In other words, if you had 3 digits, it would be 999. If you had 4 digits, it would be 9,999. So no matter how many times that we were to do that, we would say that's n times. Well, that is going to be our exponent. So that n, whatever number it is, that's our exponent. So if there are 15 nines like we had in our previous example, then it would be 10 to the 15th. If there were 27 nines, then our answer would be 10 to the 27th, and so forth. Okay? All right, so let's think about the opposite way, okay? Extremely small numbers, numbers between 0 and 1. The chance of you having the same DNA as another person, other than an identical twin, is approximately 1 in 10 trillion. That's 1 followed by 12 zeros. And given that fraction, express this very small number using a negative power of 10. Well, remember from our previous lessons that we can write this as 1 over 10 trillion, or this would be the reciprocal, so 10 trillion, which is a 1 followed by 12 zeros. So, sorry, a 1 trillion. We would have 1 followed by 12 zeros. There's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And this would be a negative exponent, right? So this would be to the negative 1 over 1. And then we can write this as, well, if we have 12 zeros, this would be 10 to the 12th over 1. And that exponent is negative, 10 to the negative 12th power. All right, so in the first two examples, we had very large numbers, and now we're talking about extremely small numbers. Okay. And I just realized I made a mistake here. This is actually to the 13th power, because we would have 12 zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and that 1 is also a digit, so that's 13. 10 to the negative 13 would be the same as what we originally had, which was 1 over 10 to the 13th power. So there we are, exercise 4. Exercise 5, the chance of winning a big lottery prize is about 10 to the negative 8. And the chance of being struck by lightning in the U.S. in any given year is about 0.00001. Which do you have a greater chance of experiencing? So let's think about place value here. We've got tenths, hundredths, thousandths, ten thousandths, hundred thousandths, and then millions. So this is 1 over 1 million, which would look like this, 1 over 1 million. And then we can write this in exponential form, and that would be 10 to the, well, we've got so look back at our original number. We have six digits here, 6 digits, so that's 10 to the negative 6th. 10 to the negative 6 would be our integer for being struck by lightning in the United States in a given year. And then 10 to the negative 8 would be your chances of winning a lottery. So that means that there are fewer possibilities in the lightning and when compared to the lottery. So you would have a better chance of being struck by lightning in a given year than you would in winning a lottery. I always tell students, you might win the lottery. You won't, but you might. I mean, the chances are there. But think about the lottery. If I were to write this as a fraction, the lottery would be 1 in. Well, I would have to move. Excuse me. I have to move my decimal, which is currently a 10. I would have to move it 8 places. So 1, 2, 3, 4, 5, 6, 7, 8. My decimal would be here. These would be zeros. So we have tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, millionths, 10 million. So 1 in 10 million. So this would be 1 in 10 million. So not a great chance there. Okay, next. There are about 100 million smartphones in the U.S. Your teacher has one. What share of U.S. smartphones does your teacher have? Express your answer using the negative power of 10. Well, 100 million, remember, is 100 followed by 6 zeros. So there's our 100 million. And we have how many digits here? Well, we've got 3, 6, 9. 9 digits, but we're not going to count that 1. So 8 digits. So this is 10 to the negative 8. 10 to the negative 8. Which is equal to 1 over 10 to the positive 8. And 10 to the positive 8 would be 8 more spaces. Sorry, 8 more zeros. So 8 zeros altogether. So this would be equal to 1 over 1 and then 8 zeros. 3, 4, 5, 6, 7, 8. There we go. And we have 100 million. All right. So we're using exponents for extremely large numbers and extremely small numbers. And you learned in this lesson how to find the next power of 10 bigger than a big number, a large positive number, and then the next power of 10 smaller than the smallest numbers, which would be between 0 and 1. Okay, and we used negative exponents in those cases. Okay, that is lesson 7. I hope that helps. I'll see you again next time.